Hello friends. So in this video, I'm going to focus on the object-oriented PLC programming. But before that, I need to touch base on the way the OT programming has evolved with the IoT and Industry 4.0 standard. And now we are going and adapting more into new way of programming, which is object-oriented programming. Okay. So let's start with the basics. So first is the programming paradigms. So what exactly programming paradigms means? So programming paradigms are basically the way or the style in which a given program or programming language can be organized. So like in OT we have ladder, FBD. So those are also programming paradigms. So basically what it is a guidelines or the set of ideals which has been agreed or defined by set of people and that has been getting followed. Okay. So here I will be giving more on the different structure. So we have imperative programming, we have declarative programming. So in imperative we have procedural, object oriented and parallel processing approach. Whereas in declarative we have logic programming, functional and the database data driven programming approach. So basically in the OT world, when we started first, uh, the most of the programming uh, languages were following functional programming. So what exactly the functional programming is, which is mostly constructed or utilizing predefined functions. So it is a declarative programming paradigm in which the function play the major roles. Okay, so we don't write most of the code. Functions are there. We pass the values and get the uh, output. Okay, so let me show you how exactly we were using this kind of approach in the PLC world. So in the PLC, we were writing most of the time the code in ladder logic. Initially, I'm talking about initial time. So let me show you an example. So this is RSLogix 5, which was used to program uh, PLC 5 of the Rockwell PLC family. So if you see here, in this particular thing, we were not supposed to or used to create our own UDT or function blocks, but we were having predefined functions. Okay, so for example, if I go to analog block and I have to create a scaling or the mapping, then we utilize multiplication blocks. Okay, define the memory addresses. Correct. So we had memory addresses concept here. We define memory addresses, and based on that, this particular function works. So it will we map the values, map the addresses, and based on the value it is getting, the output will get generated. So source A, source B, destination. Okay, let me show you some another different example. Maybe I'll go to the PID part. So so if you see, even for the PID, so right now we are writing our own PID block, but earlier it was predefined PID blocks which we used to have. Okay, so here we just map the variables and the PID blocks will work as it was defined by the uh, uh, this particular programming ID. So Logix 5. Okay, so we had compute function blocks, we had the multiplication less than equal to, greater than equal to. So all those function blocks we were using. So mostly it was part of how it was working. It was part of the uh, function programming paradigms. Okay, so where functions play a major roles in spite of our own creation, so we mostly utilize those, and we had a predefined set of variable mapping and all those where we were utilizing it. But so let me show you the controller properties. So it was utilized for the PLC 5 family of the Rockwell. If you see here the driver, it was of the PLC 5. And if I show you when this code was written, so it is a very old code. So it was almost of 2004. So this code was written. So earlier, at that time, we were using this Logix 5 mostly because uh, PLC 5 was one of the rugged PLC at that time. But even the Rockwell uh, thought to get evolved. Okay, so that is how means the new approaches come, and even those approaches were started falling into the OT part. So now if you see in this particular RSLogix 5000, we started creating our own UDTs, function block. Even if you see the structure, we had a main routine, and then in the main routine we were calling all the subroutines based on uh, the priority or the procedure which we want to execute. Okay, from the top to bottom approach, it was so. The way of programming got little change from the earlier, correct? So it started supporting creation of the new function blocks. Uh, so they were also predefined functions already present, but we can create our new function block as a add-on blocks, add-on instruction. Okay, in this one, and we were also supposed to create our own user-defined data types. So those were started supporting, and it was mostly going into the procedural programming part or the object-oriented, somehow object-oriented programming also. So uh, let me show you how exactly what is procedural programming and what is difference in between object-oriented programming, which are part of the imperative programming. So in the procedure programming, the focus was mostly on the process and the functions. But the problem was that it was not easy to maintain. So once you write starting the code, it will go bulky, and it will become very complex, and development time also become increase it will increase. So here the focus was mostly on the procedure rather than the data, which has the more priority to get in the data driven system. So in procedural programming, one of the things was that we cannot create modular, uh, and we cannot reuse them. Reusability was very less. Okay, so those were some of the things which procedural programming were having. So that is where this object-oriented programming started growing up, and because its focus was mostly on the data and the classes. Okay, so data and classes, so it was easy to maintain the object-oriented programming, the code which we were writing. It was modular, the code can be reused. It was mostly the data-driven programming language, and, and the thing was, it was uh, easy to program, and uh, creating the objects, classes, and references throughout the program where anytime you can utilize them. So the maintenance become easy and development time reduces. So let me walk you through what exactly the object oriented programming is. So this is a kind of programming. So if you see the name object oriented programming, okay, so it defines in the name that any programming which is oriented towards the objects. Okay, then what are objects? And so anything which is identifiable entity with its own characteristics and behavior is called an object. So like an example, I will take an example of car. So if you see the car, it has its own color, it has its weight, so those are its characteristics, and then behavior is like it can start, stop, accelerate, so those are the behavior. So this is the basic example which we say. So car become a class. So we define a car class, and then it has some characteristics and behavior. Similarly, in the OT side, so when we come to the OT side, we have the flow transmitters, which can be an object. We have the pressure transmitter, pressure sensor, which is also an object. We have actuators, correct? So actuators like control valves. So control valves are there, then pumps are there. So these are also, we can call them as an object, because these are the major thing which are working in the operational technology side. Okay, so IT, information technology, OT, operational technology. So let me show you how exactly both are correlated, and when we say that object oriented programming we are not at all using in OT side, and then let's see how exactly it goes. So what is the building block of object oriented programming, which is, we call it as a class. So in IT language we always utilize class. So what is the building block of the programming in OT? That is a function block. Okay, now what is class? Class is a user defined data type. What is function block? Function block is also a user defined data type. When we have to instance a class, we called it instance it using object. The function blocks are also always called via an instance. So we create an instance of the function block. That is what we call, correct? So once the object is created, then only that class takes the memory. Same thing happens in the function block also. Once the instance is created, it takes the memory. So if you see here, the class and function block are equivalent, so there's no difference. So it means, so whenever we are writing any program with function block, it is almost similar to class. So let me show you example. So I'm using this CoDeSys. We can go add object, and in add object with POU, and we define the name of the POU, which is I'm defining as a FB sensor. Okay, now select all the required field and click on the add. So a new POU will get added with its own internal feature like var input, var output, var. So these are the some variable types which are getting defined here. So now so let me define some variable and show exactly how we create a function block. So like we have input, so we will define one input in the var input side. So var input means this particular thing will read the input from the field. Okay, so now let's define a variable in the output. So what exactly we do? We read the data from the sensor, process it, scale it, and then generate the scaled output, correct? So I'm not going to write the whole logic for the scaling, but I'm just giving a brief context that I will read data from the sensor and I will pass it to the output to get utilized in the scaled output to get utilized in the logic part. Okay. So let me define one variable here, and let's in the programming, let's map these two variables. The output will be mapped with the input. So input will come and it will pass it to the output. So that is what basic program it is. Okay, so consider this is a very basic function block which we have created. Now let me save it and compile it, and let's go into the main program. So let me compile it and generate the code. So if you see here, when the code is getting generated, the FB sensor function block is grayed out because it is not utilized anywhere in the main program, or it is not, no instance have been created for this particular function block. So that is why it is grayed out, because it is not consuming any memory. So that is what we talked, correct? So until unless we do not create any instance, the function block will not utilize any memory. So let me define one instance, and let's generate the code. So instance is created, we generated the code. So let's see the memory structure. So when we generate in the CoDeSys, we get what bytes and everything, we will get it here. So if you see here, right now it got generated with 75114 bytes. Okay, so this is what the memory consumption happened. So let's let me first pin this particular message box, so it will be easier to see the differences. And let me take the one snip. So when we put an instance, the memory is 75114 bytes. Let's remove this instance and build it. Okay, so let me clean the code and then rebuild it, so it will give again the all the things of the memory, and everything will be get generated. Now let's generate the code. So now if you see, the memory got reduced to 74626 bytes, correct? So earlier it was 75114, now it is 74626 byte, because we removed the instance. So the no instance of the function block means no memory consumption. So it is similar to what we say, that even if we delete that function block, uh, it is same. Okay, because it is not at all there, so uh, there is no consumption in the memory. Okay, so let me remove it. Again we will clean all. Okay, and again we will build or generate the code. So if you see the memory, it is same, correct? So no instance or no function block, the memory remains same. Until unless we create the instance of the function block, memory will not change. Okay, so let me now create the instances again, and save it, and let's again generate the code. So the memory consumption will be same as what it was earlier with one instance. So because we define again the one instance, so it should be the same anyhow. Okay, so now let me define one more instance of the same function block. So we can create multiple instances, correct? So it is just like an object what we are creating. So pi101, ti101, so these are the different objects which we are creating, or the different instances. So if you see now, with two instances of FB sensor, the memory consumption of the generated code increases, correct? So that is how, means the function block, when we create instance, it consumes some memory. When it is consuming memory, does it has some good impact, or does it behave differently? uh, so let's check it out, how exactly this memory play the role. So let's define some variables. So let me define variable here. So I will define again, because this function block has one input, one output. So I will define one input for pi101 and one output for pi101. And same thing I will define for ti. So one input for ti101 and one output for ti101. So it is defined. So now let's call these instances into the program. So pi101, let's call it, and map it with the function block internal variables. Okay, so let's map all the things. Even for the ti101, let's copy and paste it and change the names, and change the variable names also. Yeah, so these are now defined. Let's download the code. Let's start the PLC. Okay, scan, connect, and let's download the code here. So once the code is downloaded, let's start the PLC and let's go to the main program. So as we were saying that every instance has its own memory, every instance work differently. So let's pass some values to both the instances. So now if you see, both worked independently because both has their own memories. So that is why the input and output of both the instances are different. So from this we come to know basically that the function block which we are using is nothing but that is a class. So this is just one step of the object-oriented programming. There are more to discuss. There are more things which we can utilize in the PLC programming, and we can go ahead. So I will capture those in the next coming videos.
Thanks for watching. That's all for this video. See you in the next one.